2024 A-Level Combined Mathematics Paper 1 Part B, question number 15, Part C. Parts A and B of the same question were discussed in previous videos, links in the top right. Part C of this question has to do with identities of integration. The question says, using the formula integral from 0 to a of f of x dx equal to the integral from the same limit 0 to a of, in this case, f of a minus x dx, where a is a real constant, we are asked to show that the integral from 0 up to pi by 4 of the natural logarithm of cosine of x divided by cosine of x plus sine of x with respect to x is equal to pi by 8 times the natural logarithm of a half. Now for this, what we will do is use the identity here stating that for any constant a, if we integrate from 0 up to a valid integrable function f of x, that integral is equal to the value of the integral from 0 up to a of, instead of f of x, f of a minus x with respect to x. Now in this particular case, applying that, we can see what we're asked to solve the integral from 0 up to pi by 4 of this function right here. And we can see this function has the integral form of 0 up to a, where in this case a is pi by 4. So therefore we can apply this formula that we have here. Instead of f of x, we can try f of pi by 4 minus x and see what we get. And we know that those two integrals are going to be equal in value. The value of this integral evaluated is going to be equal to the value of this integral evaluated. So given that, for this particular integral here, if we apply the same identity, we can say if the integral I is this integral, which is the integral from 0 up to pi by 4 of the natural logarithm of cosine of x divided by cosine of x plus sine of x taken with respect to x, this integral must be equal to the same integral with limits of 0 to, in this case, pi by 4 of, and on the inside, instead of f of x, we have f of a minus x, where a is pi by 4. So therefore, this is going to be equal to the integral with the same limit 0 up to pi by 4 of, and in this case, we have the natural logarithm of, and everywhere we have x, we need to substitute with a minus x, which is in this case pi by 4 minus x. So instead of cosine of x on top here, we're going to write cosine of pi by 4 minus x. And then on the bottom here, instead of this x, we have cosine of, again, pi by 4 minus x plus, and instead of sine x, we have again sine of pi by 4 minus x, and this is all integrated with respect to x. So we can write, I'll take this to a little bit to the left since I've run out of space. We can write this all integrated with respect to x. So both of these integrals are equal to each other. The integral from 0 to pi by 4 of this integral and 0 to pi by 4 of this thing are exactly the same. But if we simplify these things down, we will see something interesting which will then allow us to easily find the value of y. So considering the second integral that we found here, we can see we have cosine of pi by 4 minus x and sine of pi by 4 minus x, which we could simplify. As we know, the cosine of a minus b is equal to cosine of a cosine of b plus sine of a times sine of b. And similarly, we also know the sine of a minus b is equal to sine a cos b minus cos a sine b. And we can apply both of these to this particular situation, and we will see something interesting happen when we do so. But for now, we just have to trust the process and substitute in these values and see what we get. So I'm going to take these two formula, move them down, and I'm going to try to use them to expand out this cosine of pi by 4 minus x and sine of pi by 4 minus x and see what we get. So this is going to be equal to the integral from 0 to pi by 4 of, and on the inside here we have natural logarithm of. On top we have, instead of cosine of pi by 4 minus x, I need to write cosine of pi by 4 cosine of x plus sine of pi by 4 sine of x. So I'll write cosine of a, which is pi by 4, times cosine of x plus sine of a, which is pi by 4, times sine of x. Now on the bottom, we have that same exact thing, so I'm going to write the same exact thing, cosine of pi by 4 minus x, which is cosine of pi by 4, times cosine of x plus sine of pi by 4 times sine of x, but then we have sine of pi by 4 minus x, and sine of pi by 4 minus x according to the formula, where a is pi by 4 and b is x, is going to be sine of pi by 4 cosine of x minus cosine of pi by 4 sine of x. So substituting that in, we can see sine of pi by 4 cosine of x minus cosine of pi by 4 sine of x. And that's all we have on the inside, and then we can close that and write dx. So now with that, we have simplified this cosine of pi by 4 minus x, this cosine of pi by 4 minus x, and this sine of pi by 4 minus x. What we can do now is to substitute in the values of sine of pi by 4 and cosine of pi by 4. And when we do that, you will see exactly why we are doing this. So we know cosine of pi by 4 and sine of pi by 4 are both equal, and they are both equal to 1 over root 2. That's the reason why tan of pi by 4 is equal to 1. So substituting that in, we can see our integral is equal to the integral from 0 up to pi by 4. And on the inside, we have natural logarithm of 1 over root 2 cos x plus 1 over root 2 sin x divided by, and on the bottom we have 1 over root 2 cos x, again plus 1 over root 2 sin x, plus 1 over root 2 sin x, but then we have plus 1 over root 2 cos x, again plus 1 over root 2 cos x, but then we have minus 1 over root 2 sin x. So on the denominator we have another minus 1 over root 2 sin x, and close that dx. Now considering this thing, we can see on the bottom we have plus 1 over root 2 sin x and another minus 1 over root 2 sin x. We can cancel out these two. Now cancelling out those two, we can see on top we have 1 over root 2 cos x and 1 over root 2 sin x, and on the bottom we have 1 over root 2 cosine of x's. Now let's say we divide the top and the bottom by 1 over root 2. We can cancel this, 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 and this, leaving us with cos x plus sin x on top, and at the bottom we have cos x and another cos x, which is 2 times cosine of x. So therefore, simplifying this down, we can see this is equal to the integral from 0 up to pi by 4 of the natural logarithm of, and on the inside on top we have cosine of x plus sine of x, but on the bottom we have 2 cosine of x, so therefore we can write 2 cos x with respect to x. So we can see with the formula given in the question, we have converted this integral into another integral that looks very similar to it. And I'll show you just how similar it is by writing them out together. So the integral I was originally equal to the integral from 0 to pi by 4 of the natural logarithm of cos x divided by cos x plus sin x with respect to x. So we'll write that as the integral from 0 to pi by 4 of the natural logarithm of cos x divided by cos x plus sin x taken with respect to x. Now we have converted that integral into another integral, which is this one right here, which is the integral again from 0 to pi by 4, same limits, of the natural logarithm of, on the inside we have cos x plus sin x divided by 2 cos x, and that's taken with respect to x. Now considering these two integrals, we can see they are very similar to each other. Same exact limit, of course same exact variable, and on the inside natural logarithm, but what changes is what's inside of the logarithm. In the first one we have cos x divided by cos x plus sin x, but the second one, instead of having this cos x plus sin x on the bottom, has it on top, and at the bottom it has cosine of x, while here we have it on top. So we can see the top and the bottom have swapped, but we also have a 2 on the bottom here. So we can see not only is this thing the reciprocal in here, but it's also divided by 2. Now if you know anything about logarithms, you will know that this one and this one are very nicely connected to each other. And the reason for that is because if you consider logarithm of 1 over a, it is equal to the negative logarithm of a. Similarly, if you consider logarithm of a over b, it is equal to negative logarithm of b over a. Furthermore, another thing that we know about logarithms is that if you have the logarithm of a product, let's say ab, it is equal to the logarithm of a plus the logarithm of b. Now we can use both of those identities here to turn this thing into something interesting that we can then compare with this integral right here, and we will then see something very nice happen. So let's consider using those two integral rules here and try to convert this thing into something interesting. So considering the second one, we would like a cosine of x divided by cosine of x plus sine of x inside of the logarithm. But in this case, we have this. So in order to convert that, what we can do is to write this as being equal to the integral from 0 to pi by 4 of the negative logarithm, and when we take the negative, as we know, if you have the logarithm of 1 over a, it's equal to negative logarithm of a, and therefore if we have 1 over this thing, we can simply convert it by turning both sides upside down and writing this as the negative logarithm of, and on the inside we are going to get 2 times the cosine of x divided by cosine of x plus sine of x. And now with that, we can see we have converted this thing such that in the denominator, both our original integral and this new integral have the same exact value. Now the only problem here is, while the numerators are almost equal, this thing has an extra 2 inside of it. And we can get rid of the 2 using the fact that the natural logarithm of AB is equal to natural logarithm of A plus natural logarithm of B. Now given this, we can see we could write the thing inside as 2 times cosine of x divided by cosine of x plus sine of x. And doing so, we can also simplify this as the integral from 0 up to pi by 4. And I'll actually take this minus sign outside for now, minus the integral from 0 to pi by 4 off. And here, instead of writing the natural logarithm of 2 and this thing as 1 logarithm, we could use the fact that log of AB equal log A plus log B and write this as natural logarithm of 2 plus natural logarithm of cosine of x divided by cosine of x plus sine of x, and the sum of these two logarithms is integrated with respect to x. So now we have this. Taking this down, we can see I is equal to the integral from 0 to pi by 4 of the original one. I'll write logarithm of cos x divided by cos x plus sine x, but it's also equal to this other thing here, which if I take this minus and this part and break the integral into two pieces like so, we can see it is equal to the negative integral from 0 to pi by 4 of the natural logarithm of 2 with respect to x minus this other integral, which is the integral from 0 to pi by 4 of the natural logarithm of cosine of x divided by cosine of x plus sine of x integrated with respect to x. Now taking a moment to reflect on this, we can see the second integral that we have here is exactly equal to the first integral that we have here. You can see integral from 0 to pi by 4 natural logarithm cosine of x divided by cosine of x plus sine of x. Integral from 0 to pi by 4 natural logarithm cosine of x divided by cosine of x plus sine of x. This integral right here is exactly I. It is the original integral that we wanted to find. Now using this, we can very easily find the value of the integral I. Now taking the left hand side and right hand side here, we can see on the left hand side we have I. So we have I equals, and on the right hand side here we have negative integral from 0 to pi by 4 of natural logarithm of 2 dx, and then we have minus the same exact integral, minus I. According to that, we have 2i being equal to this integral, and over here I'm going to take the minus sign inside and write this as being equal to the integral from 0 to pi by 4 of the negative logarithm of 2 taken with respect to x. Now everything is extremely simple. It's extremely simple because all we have here is the integral of a constant. Negative logarithm of 2 is a constant, and in fact this value right here is equal to logarithm of 1 over 2. Again, because the logarithm of 1 over a is equal to the negative logarithm of a. So the negative logarithm of 2 is equal to logarithm of 1 over 2. So given that, we can see the value here 2 times I is equal to the integral from 0 to pi by 4 of this constant, which is the natural logarithm of a half. Now finally we can see if we find the value of that, we have 2i being equal to, and if we evaluate this thing, constant integral is simply going to be x times that constant. So therefore we have x times the natural logarithm of a half integrated with the limits of 0 and pi by 4. So therefore 2 times I is equal to, and if we evaluate this thing, for the upper limit we have pi by 4, so we have pi by 4 natural logarithm of half minus, and for the lower limit we have 0 here, so we have 0 times natural logarithm of half, which just becomes 0 in the end, so we can actually remove that. So what we have left is pi by 4 times natural logarithm of half, which is equal to double the integral that we want. So therefore the integral that we want is equal to half of this, which is pi by 4 divided by 2, or pi by 8 times the natural logarithm of a half. Now the integral I that we wanted to solve is this integral right here. So I'm going to write the exact integral again, which is this integral, and write that therefore the integral from 0 to pi by 4 of the natural logarithm of cosine of x divided by cosine of x plus sine of x, which is the integral that we wanted to find all along, which is I, is equal to pi by 8 times the natural logarithm of a half. And with that, we have completed this question. Now finally, let's discuss the marks awarded for this part of the question. So at the start of the question, when you use the formula that they've given and you substitute instead of x, pi by 4 minus x, for doing the substitution, you get 5 marks. After that, when you take the cosine of pi by 4 minus x and the sine of pi by 4 minus x and substitute in the relevant expressions like this, for expanding out cosine of pi by 4 minus x, you get 5 marks. For expanding sine of pi by 4 minus x, you get another 5 marks, for a total of 10 marks for this step. Now after that, when you substitute the values of cosine of pi by 4 and sine of pi by 4 like so, cancel everything out, and eventually get to this point. For getting to the point, integral from 0 to pi by 4 of the natural logarithm of cosine of x plus sine of x divided by 2 times cosine of x with respect to x. For getting to this point, you get another 5 marks. Now after this, when you use the properties of the natural logarithm to convert this into two integrals, one where you have natural logarithm of 2 and the other one where you swap the top and the bottom to get the same form of cosine of x divided by cosine of x plus sine of x, to get this far, you get another total 10 marks for applying the two logarithm identities. Now after that, when you simplify and then you see that this integral, the integral we're asking to find, is exactly the same as the other integral that we get over here by using our logarithm rules and writing this part as cosine of x divided by cosine of x plus sine of x, and identifying that and writing I here gets you another 5 marks. Now after that, using that I, when you take that I to the other side and say that 2 times I is equal to this integral, and you find the value of the integral, which is just the integral of a constant, and find the value, and eventually say the final answer I is pi by 8 times the natural logarithm of half like this. For writing this, you get a final 5 marks. And with that, that is all we're going to have for this part of the question. So I hope you enjoyed this video. If you have any feedback, post them in the comments down below. Thank you for watching, and goodbye.